All right, let's begin. Now we're going to be looking at trapezoids, which you probably looked at a long time ago in middle school or even elementary school, and you're familiar with what they look like. So we're going to look at all the properties that you probably already know and remember first, and then we'll go back and do some new stuff, things that we probably don't know, like things about the diagonals and the base angles and things like that. So starting here, trapezoid is a quadrilateral with at least one pair of parallel sides. Now it says at least one pair, which means you can have more than one pair. But if you have more than one pair, it's technically a parallelogram. So the trapezoids we're familiar with usually have exactly one pair, and that's what we're going to be working with. Okay. So these parallel sides we call the bases. Okay. Right here and right here. So those are the parallel sides. Very good. The other two sides are called the legs. Okay. And they are not parallel. And those would be here and here. And then lastly, we have some base angles. Okay, consist of the two angles adjacent to one of the bases. Okay, so if this is one base right here on the bottom, the two adjacent angles would be right here and right here. We also have a base up here, so these would also be some base angles. So we usually think of base as being at the bottom, but since we have a base at the top and bottom, we have two sets of base angles. All right. Now, like other quadrilaterals, when we don't have anything that's really congruent, like two congruent sides or four congruent sides to make a rhombus, there's not a whole lot we can do theorem-wise with it. So we look at a special version of a trapezoid, which is the isosceles trapezoid. Very similar to a isosceles triangle, where we have one pair of base or one pair of sides that are congruent, right? So that would be here. These two would be congruent. So isosceles trapezoid is one which the legs are congruent, just like an isosceles triangle. Okay. And that's where we spend a lot of our time with some of the theorems. All right. Let's see here. So a few theorems about this. These might not be as obvious, but I already mentioned one of them above. So if quadrilateral is isosceles trapezoid, then each pair of base angles are congruent. Now, so we have some base angles right here. Okay. And we also have some base angles up here. And they're color-coded to be congruent to each other. Let's give them some letters, starting bottom left and going clockwise, A, B, C, D. So that would make A and D congruent. Angle A congruent to angle D, and then angle B and angle C congruent. So two sets of congruent base angles. Angle B and angle C, all congruent. And a little theorem about trapezoids, how to prove it's a trapezoid. This is kind of crossing into what we're going to do in Chapter 10. We start proving these to be certain types of shapes. Again, let's label these the same way, A, B, C, D. Okay. And if we can show that it's a trapezoid, meaning it has one set of parallel sides, and we can show that either pair of the base angles are congruent, then it's going to be an isosceles trapezoid. So we can go through and prove somehow using algebra or something other means that angle angle A is congruent to angle D, or angle B is congruent to angle C, right? One or the other, then this trapezoid must be isosceles. We don't have to prove both. And we'll get into this more in Chapter 10 on how to actually prove them. We're not going to do actual proofs, but do it more analytically. Okay. There we go. And lastly, we're going to talk about the diagonals. So going back to diagonals like we did with rhombi and rectangles, kites. Talking about diagonals, there's always theorems of diagonals. Sometimes they're congruent, sometimes they're perpendicular. For these of an isosceles trapezoid, the diagonals are congruent. Okay. It says right here, diagonals are congruent. Therefore, if we label these the same way, A, B, C, D, right, then AC, the first diagonal segment, is going to be congruent to the other diagonal, BD. Okay. All right. So those be the theorem 3 about trapezoids. Right. Most has to do with the base angles being congruent. So when you're coming across problems to solve below, just know the base angles are congruent, and then also diagonals congruent. So far, everything with trapezoids, if they're isosceles, means everything's congruent. Okay. Notice how A and B are not congruent. One's acute, one's obtuse. Clearly looking at them, they're not congruent, so that should help you decide which two are congruent to which two. As long as you stick to the parallel sides, you're pretty safe. All right, so let's look at a few of these. Okay, and always a good idea to label everything carefully. So we have AC, 13.2 meters. That is a pretty big trapezoid. Meters a little bit bigger than a yard, so 13 meters, pretty long. And then we have BE, right? BE here, that's 8.4. And then we have DE, which we're trying to find right here. There we go. So we can see that BE and ED make up a full diagonal. So those added together, right, should add up and be congruent to the other diagonal because the two diagonals are congruent. Let's write that out in geometry here. So we know BE plus ED is congruent to AC. We have to know the geometry first, then we can go ahead and solve. So BE is 8.4. ED, or DE, what we're trying to solve for here, exactly that. AC is 13.2. Good. And then do a little bit of algebra and subtract 8.4 on both sides. And we'll have ED congruent to 13.2 minus 8.4, which equals 4.8 meters. All right, good. Moving on, Oh, we did answer the question. Always double check that. I have ED, but that's the same as DE. Looks like we're done. Moving on. Find the measure of angle R. That's over here. And remember to use your theorems. Some people are coming up right away and asking, well, I don't know how to do it. And saying, well, what theorem involves angles? And they're like, oh, I don't know. So that leads me to understand that if you're not going back to these notes and thinking how to use these theorems during the problems, that's the issue. I'm not expecting you to stare at this and just know how to do it, but probably should find something that has to do with angles and the trapezoid. And so that would not be here, that's diagonals. That would be these two. And they kind of say the exact same thing, so that limits to what you should probably use, right? So it says these base angles are congruent, and so are these, right? So if I go down here, that means if this is 77, so is this, right? So you're not expected just to know that. You can use the information you're just given. Likewise, you know these two angle R's and angle S's are congruent. You don't know what they are, but you know they're the same. So mark them as such, and it might be a little bit easier to figure out how to do this. And we know from yesterday, the first problem from yesterday, and from our test, how many degrees are in the entire quadrilateral. How many degrees do all four of these add up to? 360, right? 360. Now, if you don't know that, that comes from a formula we did a while ago that said the sum of the sides is going to be n minus 2 times 180. And if we plug in 4, substitute 4 in here for 4 sides, that'd be 2 times 180, right? And that's how everybody's getting 360. Probably have that memorized by now, right? So if you know that, we know that, well, these two angles that are 77 each, these two angles that are 77 each, right? And these two angles, which are the same as the measure of angle R, what we're trying to find, are the same. And they both add up to 360 degrees. I mean, all four of them add up to 360 degrees. And we can solve this and find out how many degrees each of those S and R are. So do a little arithmetic. You can do 2 times 77 would be 154, I believe. All right. So really just subtract 154 from 360, and we'll have how much? 206, okay. And then divide both sides by 2. So measure of angle R will be 103. And then you can always go back and add all of your angles up and make sure they do equal 360 to do a check before you turn anything in and say you're done. So always a way to check these if you know how much they add up to. Now, there's other ways of doing this, of course, because we have so many theorems. Somebody else could probably look at this and say, well, aren't in certain types of quadrilaterals, aren't the angles supplementary? And you can say, yes, these two should add up to 180 and just do 180 minus 77. That works as well. So different ways of going about it depending on which theorem you want to use. All right, lastly, it looks like it has to do with the diagonals. So that would be this theorem right here that says diagonals are congruent. I'll just label this just to make sure. Okay, so we have JL right here. And then we have KM. Okay, good. So according to the theorem above, those two are congruent. So I just need to solve, set these equal to each other and solve. So this one is a more straightforward 3y plus 6, and that's equal to 22 minus y. Right. We have, let's see, add y to both sides. Subtract 6 on both sides. do all the normal algebra we're so used to doing. And we'll come up with an answer of 4. Okay. And on this particular problem, they only want what y equals, so we are finished. Unlike the other ones, they want to know what the degrees were. So we should probably put degrees on here. Right? And they wanted to know here what the length was. So there we go. So that's probably the more familiar part of the trapezoids, but if we flip it over, we'll see something that's a little different, but not too unfamiliar. And that's to deal with an idea called the mid-segment. Okay. So it's a segment, right, whose endpoints are the midpoints of the legs. Okay. So right here and right here, these are the midpoints of the two legs, right? The non-parallel sides of the legs. So here are the midpoints. And if you draw a segment from midpoint to midpoint, you get a mid-segment. Okay. And just like on the front, just any trapezoid, it's not too important, but if we make it, well, actually, no, sorry. This does work for any trapezoid. Yeah, it doesn't have to be isosceles. Okay, so define the mid length of this the length of this mid segment. If I want to find how far it is from here to here, it's kind of like finding the midpoint, where you just take the 2 points and you add them up and divide by 2. But in this case, we're taking the 2 bases and adding them up divided by 2. So it's kind of like this: base 1, right up here, base 2 down here, add them up, okay, and divide by 2. And that will equal the length of the mid-segment. Okay. And don't worry about this language here. It's accidentally copied. It's the same as it is here. So if you want to, you can write in the same, or you can just don't worry about it. There we go. Okay. That's the formula. It's just like anything else. Just like if you guys were finding the midpoint, like if you're given an x and a y and you found the midpoint, you did x1 plus x2 divided by 2. Same idea here. It's just base 1 plus base 2 divided by 2. Hasn't changed. Find the middle of something, the average of something. It's all the same, okay? So don't think of it anything different other than what it represents. Instead of representing a point, it's now a length. Okay? So let's just do a couple here. So in this case, we have when both bases are given. Okay? So the average of this pink and blue should be the length of the green. So if I have, let's see here, 12.5 plus 10.3, and then divide it by 2, right? That will be xy. And of course, that means if this is the mid-segment, this is the value should be exactly in the middle of 10.3 and 12.5. So if you get an answer bigger than 12.5 or smaller than 10.3, you know something's up, something's wrong. So this is nothing more than adding them up and dividing by 2, just like taking the average back in elementary school. So 12.5 plus 10.3 come out to 22.8. And 22.8 divided by 2 is, half of 22 is 11. Half of 8/10 would be 4/10. So we get 11.4, which makes sense. That's between 12.5 and 10.3 exactly. You'd be surprised how often somebody will get an answer like, oh, it comes out to 30, and they'll just write in there, the answer's 30. That's the middle of 12 and 10, is 30. So check your answer. Make sure you actually divide it by the 2, things like that. All right. So here is on number 3, the other part where they actually give you one of the bases, 8.3, and the mid segment, which is 9.8, and want you to find the other base. In this case, it's JM. Should be a J right here. Okay, so we're trying to find out, in this case, what this length is. So using the same logic, like this is definitely the longer of the two bases. This is 8.3. JM is clearly appears to be longer. So when we get an answer, it should be bigger than 9.8. And more accurately, it should be the middle. This plus 8.3 should give us the middle answer of 9.8. Okay. So let's do it the same way. I'll have my length here, 8.3, plus the other base, which is what I don't know. I'm trying to find out, JM. Right. All divided by 2 equals the mid segment. Now, before we didn't know, we just called it XY. This problem, we do know what it is. It's 9.8. Right. There you have it. So there's the equation we need to solve. Start off by just multiplying both sides by 2. Right, so we have a 2 times 2 here, divided by 2 here, so the 2 divided by 2 cancels out. And now we're just left with 8.3 plus JM equals twice of 9.8, which is 19.6. And subtract 8.3 on both sides, and we'll find out that JM is 19.6 minus 8.3, which would be 19 minus 8 would be 11. 0.6 minus 0.3 is 0.3. So our missing side we got to be 11.3, and it's important that our answer was bigger than 9.8, so that makes sense. All right, so there we go. So if I was to add up 8.3 and 11.3 and divide by 2, that would give me the 9.8, the middle segment. Is 18, and 2 times 0.8 would be 1.6. 18 plus 1.6 is 19.6, I believe. Double check. Yeah, I think that's right. Good. On the rest of these, it's pretty much the same. So if we scroll down, you'll see that 4 and 6, yeah, pretty much like the front. All these 3, 4, 5, and 6 are pretty much like the front from these problems, A, B, and C. I'll reference those. Then we get down here, and 7 and 9 are kind of like the first example we just did, where they give you the endpoints. Just add them up, divide by 2. That gives you the mid-segment. Okay, so you can see they give you the 2 bases. And then you see 8 and 10, they give you the base and the mid-segment on each one of these, the base and the mid-segment. That's kind of like number 3 right here, we just did. So there's clear examples for each one of those. Just follow them closely, and they will work out. If you like the color and it works for you and it helps you, use it. Down here is the same thing, but with algebra. So don't change anything as far as how you approach it, do exactly the same thing. It doesn't matter if they're numbers or algebra. It doesn't change how you solve it. So, for instance, here, it'd be 12 plus 6x, right? All divided by 2, which will equal 4x. And very similar to this example, you go through, multiply both sides by 2, and then solve the equation that's remaining. Okay? Everything is doable. You have examples for everything. Just follow it carefully, and it should be okay. As always, I suggest for every class, no matter what grade or what college you're at, if you have time in class to start work, start with the hardest problems first. Get those done, so if you have questions on them, at least you get that answered and they're done before you leave here. And you walk out the door thinking, well, I got homework, but you know what, the hardest part's done. And it's easier to make sure you get the rest of it done on your own. You know, it's just the more basic stuff like here, adding up two numbers, dividing by 2. So always a good way of going about any class, okay? All right, so you have the remainder of the class, whatever that may be, to get things done, and you guys can have the rest of the class to work.